Okay, we're back, and we're going to use Grignard reactions and synthesis problems this time. So, let's make that our topic. Using Grignards in synthesis. And the thing you're going to be looking for in synthesis problems when you have a Grignard reagent is to see if a carbon-carbon bond formed. So we're going to call this using Grignards in synthesis to form carbon-carbon bonds. Okay, so let's start with an example. Let's say that we have this alkyne and we're trying to turn it into this ketone. So one of the things you should always do in synthesis problems from now on is to count your carbons and see if there are any carbon-carbon bonds that need to be formed. So if I look at my starting molecule, I have 1, 2, 3, 4 carbons. But in my product, I have 1, 2, 3, 4, 5 carbons. So I need to form a carbon-carbon bond. Need to form a carbon-carbon bond. And there are only 2 ways to do this, at least that we've learned so far. So the first one is what we learned in the alkyne chapter. We can deprotonate a terminal alkyne, like the one we have here, and then we can do an SN2 reaction on it. So we can deprotonate a terminal alkyne. Then do an SN2. And that's one option, and maybe that'll work here. The new option that we have in this chapter is that we can use a Grignard reaction. It's not always the best choice, but a lot of times it's more versatile than using the terminal alkyne, because in terminal alkynes you're stuck with the fact that you have to do an SN2 reaction on a primary alkyl halide. So sometimes that's a limiting factor. Sometimes you can't get the steric crowdedness that you need. So let's first look at option number 1 for this reaction and see if it works, and then we'll compare that to option number 2. Okay, so trying to do this with the terminal alkyne. So let's try a terminal alkyne. Okay, so back in the alkyne chapter, we learned that the best base to deprotonate a terminal alkyne was a really strong base, sodium amide, NaNH2. And once you deprotonate the terminal alkyne, then you can add on any primary or methyl halide that will do an SN2 reaction. So in this case, if we just want to add 1 carbon, we're going to add methyl iodide or methyl bromide, whatever your favorite halide is, and that's going to add 1 carbon. So we'll have 1 extra methyl group on the end. So now we have our 5 carbon chain. That's great. But then the product that we're trying to get to, don't forget, looks like this. We want to get to this ketone here, and the ketone needs to be on the 2nd carbon from the right. Well, I have a way of turning a triple bond into a ketone. That's with a hydration reaction, so H2SO4 and HgSO4, or the anti-Markovnikov version of that would be to do a hydroboration. But the problem is that both sides of this triple bond are equally substituted. And so the fact that this gives Markovnikov addition or anti-Markovnikov addition doesn't really matter. We're going to end up getting the OH group adding to either carbon, and then after it tautomerizes, we're not going to get exclusively this ketone. We're also going to get this ketone, where it ends up on carbon 1, 2, 3 instead of 4. And so there's really no way to avoid a mixture of products here. Even if you try hydroboration, you're going to run into the same problem, is that Markovnikov versus anti-Markovnikov addition doesn't matter here. So this always gives a mixture of products. This won't work because it gives a mixture of products. Okay, so that was our attempt with the terminal alkyne. So our new method of making a carbon-carbon bond is to do a Grignard reaction. So let's try that. Let's try a Grignard. Okay, so for Grignard reactions, it helps a lot to think backwards. So I'm going to draw the product here that we're trying to make. And remember that one of the pieces that we start with has 4 carbons in it. So what we have to do if we're thinking backwards is to count our carbons from one end to the other. 1, 2, 3, 4. So it would make sense if I'm thinking backwards about the pieces I need to build this molecule to imagine cleaving the molecule right there. That'll put 4 carbons on this side and then 1 on the other side. And then the other thing that I'm going to think about is which side of this molecule should be the Grignard reagent and which side should be the carbonyl compound. And if you have a carbon that is already attached to an oxygen in your final product, it usually makes more sense to make that side the carbonyl compound. And then the other side can be my Grignard reagent. So that means my 2 pieces that I'm going to need here are an aldehyde that looks like that, and then a methyl Grignard. So once I think backwards about what the pieces are that I need, then I can go in the forward direction. I'm not starting with this piece. I'm told that I have to start with this alkyne. But I know a one-step reaction to turn it into this aldehyde. That's a hydroboration reaction. So I could use 9-BBN, or there's another option there. But I'm basically doing a hydroboration to an alkyne. So I'm going to work this up with hydrogen peroxide and hydroxide ions. This is going to give anti-Markovnikov addition of an OH group, and then there's a tautomerization that happens. And so I end up getting the aldehyde that I want at the end of this reaction. Next, I'm going to add my Grignard reagent. This is a carbonyl, so it's ready to do a Grignard reaction. So remember with Grignards, we always add the Grignard reagent first, but then we have to work up the reaction with water to protonate everything and quench that Grignard. And when the Grignard adds, it's going to add a methyl group to this carbon. But remember, as this adds, it turns the carbonyl compound into an alcohol. So after I do the Grignard reaction, I'm not going to have a carbonyl anymore, I'm going to have an alcohol. So I have that secondary alcohol there. But my goal was to have a carbonyl compound, so now I have to think through all of those reactions I learned about alcohols and figure out, well, what kind of reaction takes me from a single bond to an oxygen up to a double bond to an oxygen? That's an oxidation reaction. And so I'm going to erase my backwards picture here just to put in the last step. But now I'm going to choose whatever oxidizing agent is going to get me to this, back to this ketone. And in this case, it's a secondary alcohol. Any of your oxidizing agents that you learned will work. So I'm just going to use the classic sodium dichromate with a little H2SO4, but you have about 4 other choices that you could use here that would work equally well. Okay, so there's our Grignard reaction. That worked in a case where the alkyne reaction did not work to make the carbon-carbon bond that we needed. Okay, so now let's have you try one on your own. If you go to your worksheet, problem number 3 on the worksheet is an example of where you have to use a Grignard reaction in a synthesis problem. So this would be a good time to pause the video take a few minutes to try number 3 on your own, and then come back and see what the answer is. In the meantime, I'm going to write down the problem. So this is the worksheet that says Grignard reactions and protecting groups. And what we're trying to do is to turn these 2 molecules into the product shown. So we want to turn it into something that looks like that. Okay, so again, I'm going to suggest that you look at your product and think backwards. Look at the pieces you're starting with. For example, here you have 1, 2, 3, 4 carbons, and this double bond matches up nicely with this piece of the product molecule. 1, 2, 3, 4. So it seems like the best place to cleave this molecule would be right here, so that you have a 4 carbon piece, and then on the other side you're going to have 1, 2, 3 carbons, which matches well with 1, 2, 3, the other reactant. Let's make sure we read the rules correctly in this problem. It says that all carbons in the final product must come from the indicated starting material. Okay, so these carbons that I start with in my reactants, they all have to be the carbons that end up in my product molecule. I'm not allowed to throw in a different reagent that's going to supply those carbons. So that's something to be careful about in the rules. Okay, once I figure out where I'm going to cleave this, then I have to think about, well, what are the 2 pieces? Which side's going to be the Grignard reagent? Which side should be the carbonyl? I see a carbon over here that is attached to an oxygen, so it makes more sense for this to be the carbonyl side of my molecule, and then over here, this is going to be my Grignard side of the molecule. So thinking backwards, that means my 2 pieces are going to look like a Grignard reagent, MgBr, and my other piece over here is going to look like a carbonyl. In this case, it's just going to be an acetone molecule. Okay, so once I figure that out, now I just have to think about how I'm going to turn each of these 2 pieces into the 2 structures shown here. So I'm going to start with the one on the left. That one is just a 1-step reaction, so that's pretty easy. Secondary alcohol, turning it into a ketone. That's an oxidation reaction, and any oxidizing agent will work. So maybe this time I'll use some NaOCl, some pool chlorine. Okay, so I get that ketone. And now at this point, I'm just going to save it. I'm not going to use this in the next step. I'm going to use that later in one of the steps when I need it. Over here, this OH is not what I want in a Grignard reagent. I would like this to be a bromine so that I can then add magnesium and make the Grignard reagent. So we learned in the last lecture that if you have a secondary alcohol, the best reagent for turning this into a bromide is going to be PBr3. Once I turn that into a bromide, then I can turn it into a Grignard reagent by adding magnesium. So that's going to turn it into MgBr. And I'm running out of a little room here, so I'm going to erase my backwards thinking now. You might have more room on your piece of paper. And now I'm ready to do the Grignard reaction. So the Grignard reagent I just made can react with the ketone that I had made earlier. And remember, this is always done in 2 steps. There's my ketone. I have to quench the reaction with water. And now I'm going to have something, I'm going to draw it up here. That carbonyl is going to turn into an alcohol. And that was exactly what we were trying to make, so that's the end of the problem.